Okay, good morning all of you. So I think you will be well and studying well. Okay, so we will start the topic of chapter number 24, that is heat engine or second law of thermodynamics. Second law of thermodynamics. Okay, so in this particular second law of thermodynamics, we will discuss about the what are the demerits of first law of thermodynamics and what that means what are the drawbacks of first law of thermodynamics, and we will discuss about the what is the second law of thermodynamics and what are the application of second law of thermodynamics we will discuss in this particular video. Okay, so first let us learn what are the what are the limitation of first law of thermodynamics. Okay, there are 3 to 4 limitations are there. Just you have to cover first what are the limitation, then after we will go to the second law of thermodynamics. Okay, first limitation says that the first law of thermodynamics simply states that the equivalence of mechanical work, heat, and when one is completely converted into others. Okay, and it does not tell about the at what condition the first, that means the whatever the heat energy we have supplied, that will be converted into work done. Okay, so that means the first law, according to first law of thermodynamics, whatever the heat we have given to a system, that will be used to increase the internal energy plus the work done. Is that no? So, but first law of thermodynamics, it does not tells about the at what condition the heat energy, whatever the heat energy, that will be converted into work done. That does not tell about does not tell by the first law of thermodynamics. Okay, so second condition tells that it does not tells about the direction of heat flow. It does not tells about the direction of heat flow. That means on which direction the heat is going. It does not tells about that thing also. First law of thermodynamics. Third condition, this law does not provide any information regarding the nature and source of heat. Okay, that means from where the heat energy is coming. Okay, that means from the what are the source of heat energy, that doesn't also tell by the first law of thermodynamics. So first law of thermodynamics does not tell us about the what are the source of heat energy. What is the source of source of heat energy, that is also not told by the first law of thermodynamics. Okay, so these are the 3 limitations of first law of thermodynamics. Then we will go to the second law of thermodynamics. Second law of thermodynamics is given by two scientists, three scientists. That means the first one is the two statements are there. First one is the Kelvin-Planck statement. First statement given by the Kelvin-Planck statement. First statement is given by the Kelvin-Planck statement. Second statement is given by the Clausius statement. Clausius statement. Okay. So there are two statements of the second law of thermodynamics. There are two statements of the second law of thermodynamics. First statement was given by Kelvin-Planck statement, and second statement is given by the Clausius statement. Second statement is given by the Clausius statement. Okay. So first comes to the what is the Kelvin-Planck statement? What does it tell that? Okay. So Kelvin-Planck statement says that it is impossible to convert all the heat extracted from a hot body into work. Okay, so it is impossible to convert all the heat energy extracted from a hot body to a what into work. That means whatever the from the hot body, whatever the heat energy that will be produced. Okay, from the hot body, if it is a hot body. Okay, it is a hot body. So whatever the heat energy that will be produced from the hot body, okay, that will be whatever the heat energy that will be produced from the hot body, that will not be directly converted into work done. Okay, that will not be directly converted into work done. So that means it will not. That means whatever the heat energy, if heat energy is 100%, heat energy that will be given to a system, that means 100% to work done cannot be done. 100% to work cannot be done. Okay, it is impossible. So Kelvin-Planck statement tells that it is impossible to convert all the amount of heat energy, from a hot body into work. Okay. So second statement was told by the Clausius. Second statement was told by the Clausius. What the Clausius told that? Clausius told that it is impossible to transfer the heat from a cold body. It is impossible to transfer from a heat from a cold body to the hot body without expenditure of work and external energy source. Okay, so that means it is impossible to transfer the heat from a cold body to the hot body without expenditure of the what external energy source. Without external energy source, we cannot convert the heat from a cold body to the hot body. We can transfer the hot heat from the hot body to the cold body. We can, but we cannot transfer the heat from the cold body to the hot body. Okay, so for this reason, one what external energy source is required. Okay, so that is told by the what Clausius statement. So, best example of what second Clausius statement, that is what refrigerator. In the refrigerator, what will happen? Refrigerator actually, the whatever the cold energies are there, cold heat energy is there, that will be converted into hot energy. That will be converted into what surrounding to the hot. So that means whatever the heat energy that is produced in the cold body, that will be converted into what surrounding. Okay. So in the refrigerator, a working substance takes the heat from the cold body, and it will be converted. Net amount of work done will be done on the system, and the heat will be transferred to the surrounding after that. Okay, so second law of thermodynamics cannot be proved directly. Okay, so for this second law of thermodynamics, that means to study about the second law of thermodynamics, we should first also learn about what is a reversible process and what is irreversible process. Okay, so a reversible process means what? What is the definition of reversible process? A reversible process is one which can be reversed in such a way that all the changes taking place in the direct process, that will be repeated in the inverse order and the opposite sense, and no changes are left in any bodies taking place in the process or in the surrounding. That means that tells that actually what does it mean? It means that whatever if a process that is reversible, how can you call that the process is reversible? This is the statement, but how, if you just clarify the statement, then what will you produce? That means if a system that is moving from state A to state B, okay, it is moving from state A to state B, okay. So that means by the what if you just expand, or if you just giving the heat to a system A, that will be moved to system B, okay, state of B state, this is A state, okay, and back to the C, through the C, whatever the right process in the C, okay. That means from the system A, okay. So from at the state A, the system will be converted into one state to another state, okay. So if you just whatever the changes that will be occurred in the first state, okay. So if you just that will be repeated in the inverse order, that will be whatever the state that we have followed in the first process, that process. If that the same process will be repeated in the indirect process also, or in inverse order in the opposite sense, then we call as it is a reversible process. Then it will call it the reversible process. Example, Carnot cycle. Carnot cycle is a reversible process. Okay. To condition of reversibility, what is the condition of reversibility? First condition is that the process should be takes place infinitely slowly. That this process should be what infinitely slowly occurs, and this in this particular process, the dissipative force such as the friction, viscosity, elasticity, electrical resistance, okay, and magnetic hysteresis must be what completely absent. These particular factors must be absent so that the system will be a reversible one, okay. And second one is called as the irreversible process. Second process is called as the irreversible process. First one is called as the reversible process. Okay. Second one is called as the irreversible process. Irreversible process. So what is irreversible process? Irreversible process is the what opposite of reversible process. That means any process which is not reversible. Any process which is not reversible exactly is called as the irreversible process. Any process which is not reversible exactly in that particular process is called as the irreversible process. Okay. So that means there are different all the practical process, that means free expansion, heating, electrical heating of wires, diffusion of liquid or gases, that is called of the irreversible process. The example of it is the irreversible process. Okay, and also roasting of iron, in that particular the roasting of iron are also called of the irreversible process, or dissolving salt into water. Okay, these are the similar several examples of irreversible process. Okay. Then comes to conversion of heat into work or heat engine. Okay, so conversion, how can you convert the heat into work? Conversion of heat into work. Conversion of heat into work. How can you convert the heat into work? Or it is called as one engine is there, that is called as the heat engine. One engine is there, that is called as what? Heat engine. Okay. So what is the definition of heat engine, and how it works? How it works? Question will come like, what is the definition of heat engine and how the heat engine will work? Okay. So first we'll discuss about the what is the definition of heat engine. Any cyclic device by which the heat is converted into mechanical work. Okay, it is a cyclic device. It is a cyclic process, and in which what is the heat will be converted into mechanical work. Whatever the heat energy that will be given by the given to a system, that will be converted into mechanical work is called as that particular engine is called as the heat engine. Okay, and there are three different parts are there. First one is the source, the second one is the what working substance, the third one is the sink. Okay, there are three substances, there are three three parts are there of the engines are there. One is the source, the second one is the working substance, and third one is the what sink. Okay, so you just follow the figure number 1 in 787 pages. It will be it has been given. Okay, so in this process what will happen, the whatever the working substance are there, whatever the working substance are there, okay, in this particular process what will happen, we will see that if it is a working substance, so then after the it will be converted into the sink also. Okay, it will be converted into the sink. Okay. So this is the source and this is the working substance. Working substance. This is the sink. This is the sink. Okay. So source means what is source? What is the definition of source? Source means an infinitely it is a temperature. This is a kept at a high temperature. That is the T1 temperature. It is the T1 temperature. Whatever the heat that will be provided, that is called the Q1. Q1 heat will be provided to the what working substance. Okay. Whatever the heat that is inside the source, so some heat are there, that is called the Q1 heat are there, and it is a heat reservoir. It is a heat reservoir having the infinitely heat capacity. Heat capacity. Okay, it is a heat reservoir having the infinitely heat capacity. Okay, so in this reservoir, what will happen? So a source means the working substance is taken from the working substance will take the heat from the source. Okay, and convert a part of it to the useful the work, and the rest of the heat energy that will be used to what that will be transferred to the sink. Okay, so that means whatever the heat that will be given by the Q1, that means from the source, the whatever Q1 amount of heat will be transferred to the working substance, and whatever the rest amount of heat that will be transferred to the Q2 amount of heat will be transferred to the sink. Okay, so W equal to Q1 minus Q2. W equal to what? Q1 minus Q2. Okay, so what is the efficiency? How can we find out the efficiency? Efficiency means efficiency. How can we find out the efficiency? Efficiency means work done, net work done. Okay, by heat given or heat supplied, heat absorbed. Okay, so if you just write down work done divided by heat absorbed, then what will your answer? W, heat work done means W, isn't it? So I'm just writing here. Efficiency eta equal to W by Q1, isn't it? So W is the work done. This is the what heat given by the source. Okay, so whatever the heat given by the source, that is Q1, and W is the work done. Okay, so W divided by Q1, so W means what? Q1 minus Q2, isn't it? Q1 minus Q2. Okay, so Q1 minus Q2 is the work done and divided by Q1, isn't it? So that Q1 is still it will be cancelled. So Q1 by Q1, okay, minus Q2 divided by Q1, isn't it? So it will be, so it will be 1 minus Q2 divided by Q1. This is the efficiency of eta. This is called what? Eta. Okay, this is called as eta. This is, that means if Q1 is the less than, that means Q2, whatever the value of Q2, that will be always less than that of Q1. That means Q1 will be almost, that will this must be greater. Q1 must be greater than Q2. Okay. So if the since Q1 Q2 value is less than the Q1, so value of the eta is less than 1. So that means if Q2 equal to 0, in this particular condition, no heat will be given to the sink. That means whatever the amount of heat that will be given by the source, that will be directly converted into work done. Okay. Then for the particular petrol engine, the efficiency is 30 to 40%, and for the diesel engine, the efficiency is 50 to 60%. Just you have to remember what is the efficiency of a petrol engine. Whatever the vehicles that are moving in the petrol engine, in this particular vehicle, the efficiency will be what, 30 to 40%, and for the diesel engine, the efficiency will be 50 to 60%. Okay. So these are all about the heat engine, or how can you convert the heat into work. Okay. Then we will study about the Carnot ideal heat engine. Then we will study about the Carnot ideal heat engine. Okay. What is the Carnot ideal heat engine? So Carnot ideal heat engine. So what is the Carnot ideal heat engine and how it will work? How it will work? How the Carnot ideal heat engine it will work? Okay. So Carnot, first of all, you should know about the Carnot ideal heat engine. It is a reversible process, or it is a reversible one, or a reversible. So Carnot engine is a reversible. That means it can be reversed. Okay. So it will in the particular it is a reversible engine. Okay. So in this particular engine, what will happen? The working substance takes the required amount of heat. In this particular engine, the working substance goes through a cycle of process. Okay. It takes the heat from the hot body and converted a part of work into work, and what the rest amount of heat into cold body also. Okay. So it will also act in the same principle as the heat engine. Okay. So what is the Carnot? It is a reversible heat engine. Okay. And the Carnot ideal heat engine, that means there are some, what I'm just making the figure. What is the mode of Carnot ideal heat engine? Okay. This is the what, working substance. Okay. This is the working substance, and there are different states are there. This is the, this is in the hot body, or it is called as the source, and it is having the temperature of Q1. It is having the temperature of Q1, and then it is called as the insulating stand. Insulating stand. Okay, and third one One is called as the, okay. So that is called as the sink, or it is a cold body, you can call it as cold body also, okay. And having the what it is having the temperature of it is whatever the remaining amount of temperature that will be what given to the sink, okay. This is the value of the